Hi, welcome to WOW TV. My name is Angel and I'm here from the Wizards of Wright program. The WOW program is a part of the Educational Outreach Office here at Wright-Patterson Air Force Base. Today we'll review what you learned in our first lesson on straw rockets and allow you to run more launches while testing a new set of variables. Are you ready to get started? Let's go. In our previous lesson, we learned what a rocket is and how a rocket works. Let's take a few minutes to review. We already know that a hot gas is pushed out of the rocket's nozzle at such a high speed and force that the rocket is pushed forward and upward. We also learned that a rocket is a hollow cavity keeping a gas under pressure. Inside the rocket's engine, when the fuel is burned, it causes the gas to heat up. A small opening at one end allows the gas to escape in one direction, providing thrust. Thrust allows this force to overtake gravity and propel the rocket skyward. We also talked about the gas escaping in one direction, propelling the rocket in the opposite direction as an explanation of Newton's third law of motion, which states that for every action, there is an equal and opposite reaction. The action, the rocket pushes the gases down, and the reaction, the gases push the rocket up. Let's review the main parts of a rocket that we learned about and added to our rockets last time. First, we have the rocket body, sometimes called a body tube and sometimes called the fuselage. The body holds the propellant, a combination of fuel and a chemical similar to oxygen, and the rocket engine. Then we learned about the nose cone. This is where the cargo is, sometimes called the payload. This can be astronauts, satellites, or other materials. The last thing we added was fins. Remember that airplanes have wings and rockets have fins. Fins keep the rocket stable and flying straight. As the designer and engineer, you need to consider the size, shape, number, and placement of your fins. The addition of fins to the rocket helps ensure stability. As air flows over the rocket, it exerts a force on anything it touches. The parts of the rocket with the most area feel the strongest forces because there's more surface for the air to push against. By adding fins to a rocket, we're increasing the area at the rear or bottom end of it. This means that if the rocket starts to waver off course, the wind flowing past will hit its fins and straighten it out. With our last lesson, you tested variables affecting the nose cone and fins. Today, when you design and test your straw rockets, you can make changes to the nose cones and fins again, as well as test other variables. Remember, you can only test one variable at a time. If we make more than one change per test, we don't know which variable is causing our result. When scientists test variables, it's to prove a prediction or a hypothesis. We have no proof if we can't say which action is causing our reaction. The student data sheet will give you directions on what variable to test and how. Teachers, we'll pause here as you pass out the packets and take some time to discuss today's tests, which will include rocket length, nose cone mass, launch angles, rocket mass, and changes to the fins. I'll wait here, and when you're ready, we'll talk about building today's rockets. Today we introduce some design constraints that need to be applied to the rockets you build. Unless, of course, that's the variable you're testing. Your rockets should have a minimum of 2 fins and a maximum of 5. The body of the rocket should be a minimum length of 10 centimeters and a maximum length of 20 centimeters. The amount of clay used for the nose cone should have a maximum diameter of 2 centimeters when rolled into a ball. Today, you'll work with a partner. You'll work together to build your rockets and take turns with your launches, but you'll both be responsible for recording data on your own sheets. Let me quickly remind you how to prepare the nose cones and fins. Don't forget to knead the clay to soften it and carefully shape the clay. Press the clay onto the straw and shape it to the nose cone shape that you want. Make sure that the clay is solidly attached to the straw and makes a good seal. Some of the clay can go into the straw to help it stay on. Drag a little of the outside edge down onto the straw to seal it. Like with your last lesson, draw your fin shape on an index card. You can use the template included. Cut out the fins and then tape the fins onto the bottom of the rocket. Attach the fins so they're evenly spaced around the straw. Do not have any excess tape hanging off the rocket. Teachers, as your students are finishing their rockets, go ahead and set up the rocket launchers. Remember, the launchers can shift a little during launch, so if you put a piece of tape on the floor, the students can line it up again for each new launch. Before you start building, let me remind you how to correctly use the launchers. First, make sure they're flat on a solid surface, like the floor. Adjust the angle of the launch tube to the desired degree mark, and then place your rocket on the launch tube. If the launch tube moves, carefully move it and the rocket back in line with the desired direction angle. Raise the launch rod to the desired height. By varying the launch rod height, you can control the distance of the rocket's flight. To launch, release the launch rod so it falls to the bottom of the cylinder. This action compresses the volume of air in the cylinder and forces it out of the launch tube, blasting the rocket away from the launcher. When rockets are launched, simply release or drop the launch rod. Avoid forcing the rod into the cylinder. Eye protection is available when the launchers are in use. Teachers, I'll turn it over to you now. The students will need their materials, the build directions, and the data sheets. As we are paused, you can leave these reminders on the screen while you're launching. Before launching a straw rocket, clear all people from the rocket's flight path. When launching the rockets, the launch rod simply needs to be released or dropped. Avoid forcing the rod into the cylinder. The straw should fit over the tube and be able to slide freely up and down. If the straw is too loose, air will leak between the straw and the tube, decreasing the distance the rocket will travel. Launches need to be performed on a smooth, flat surface. When you're finished, I suggest discussing results as well as the factors that made rockets go higher and farther. Thanks for joining me today. And teachers, thank you for using this WOW lesson. Please check out more at our website at wpafbstem.com.